a last set of problems on electric field. An infinite line charge means line conductor produces a field of 9 into 10 raised to 4 newtons per coulomb at a distance of 2 centimeter. Calculate the linear charge density. Here is the line charge conductor, positively charged. The charge density is positive means, okay, the charge is positive at a distance of 2 centimeter. So here is the field E bar. E bar is 9 into 10 raised to 4 newtons per coulomb. Lambda is question mark. What is the linear charge density? A simple question. Okay, E is equal to field E, only magnitude is given, 9 into 10 raised to 4 newtons per coulomb. Therefore, what is the magnitude of the electric field at a distance R? R is equal to 2 centimeter, 2 into 10 raised to minus 2 meter, lambda is question mark. Okay, so E formula is for a line charge conductor, for a line charge infinitely long, uniformly charged line conductor wire, the field at a point at a distance R from the line is lambda upon 2 pi epsilon naught into R. So 1 upon 4 pi epsilon naught is 9 into 10 raised to 9. That's why let us make it 4 pi epsilon naught by multiplying 2 in the numerator and multiplying 2 in the denominator. 2 into 2 is 4. 4 pi epsilon naught R. 1 upon 4 pi epsilon naught into 2 lambda upon R. Okay. Now E is given 9 into 10 raised to 4. So suppose E bar is taken, then you have to put n cap here. Direction is to be given, n cap is the direction. But so here direction is not necessary. Field is already given. Magnitude of the field is given. Only E is given. Therefore, don't put n cap here. Okay. E means magnitude only. In that case, don't put n cap. This is the magnitude. N cap on the set field E bar could be. But E bar is there. Only magnitude is there. Therefore, E bar don't take E bar. It is 9 into 10 raised to 4. 1 upon 4 pi epsilon is 9 into 10 raised to 9. 2 into lambda. R is 2 centimeter. 2 into 10 raised to minus 2 meters. Okay, therefore lambda is equal to, by cross multiplication, 2 cancels, cancel over there. Then lambda is equal to, by cross multiplication, 9 into 10 raised to 4 into 10 raised to minus 2, by cross multiplication, the denominator quantity ಮೇಲೆ ಬರಬೇಕು, ಇಲ್ಲಿ ಬಂತಾ 10 raised to minus 2, upon 9 into 10 raised to 9, 9 into 10 raised to 9, denominator upon 9 into 10 raised to 9 ಬಂತಾ, ಹೌದಾ? Now 9 cancels, what remains? It is 9. Myself will draw 9 and cancels. Therefore, here it is 10 raised to, only 10 quantity remains, 10 raised to 4, a raised to m into a raised to n is a raised to m plus n plus of minus 2, that's equals to minus 2, a raised to m into a raised to n is a raised to m plus n plus of minus 2. And a raised to m upon a raised to n is a raised to m minus n, therefore minus 9. A raised to m into a raised to m, m and n may be positive or negative numbers, that's equal to a raised to m plus n, a may be 10, 10 raised to m, 10 raised to m, 10 raised to, okay, 10 raised to m upon 10 raised to n equal to 10 raised to m minus n. Therefore, this 9 goes to the numerator, a raised to m upon a raised to n, a raised to m minus n, a raised to m into a raised to n is a raised to m plus n, plus of minus 2 minus 2. Total it is 4 minus 2 minus 9, that's equal to minus 7 coulombs per meter. Therefore, Q is equal to not 9, I'm sorry, simply 10 raised to minus 9, 7 coulombs per meter. What is the SI unit of lambda? Lambda is the Q upon L. Lambda is equal to Q divided by what it is? L. L is the length of the line conductor. Q is the charge on the length L. Therefore, lambda is equal to Q by L. Q is in coulombs and L is length on a line conductor. On a line conductor of length L, a charge is stored Q. Then the linear charge density Q, linear charge density, same symbolic lambda. Lambda is equal to Q by L. Lambda is equal to Q by L. Q is in coulombs, L is in meters. Okay. That's all. So second question, a point charge of 2 microcoulomb. Micro is 10 raised to minus 6. Always SI unit should be taken here. Centimeter is converted to meter. So charge should be in coulombs and distance should be in meters by 2. Area should be in meter square, like that. SI unit should be used in the problem. Microcoulomb. Micro means it is 10 to the power of 2 microcoulomb, 10 to the power of minus 6 coulomb is at the center of a cubic Gaussian surface. So the charge is placed inside a cubic box. Okay. What is the net electric flux? through the surface. A simple question. Gauss's law is to use it. Q is equal to 2 microcoulomb is equal to 2 into 10 raised to minus 6 coulombs. Suppose a charge is placed inside a closed surface, then electric flux passing through it is one simple formula according to Gauss's law. It is equal to Q upon epsilon naught. The size and shape of this particular Gaussian surface is not material. Q upon epsilon naught, whatever be the shape and the size. So the flux through that closed surface, inside a closed surface, so the charge is placed inside the closed surface. So it may be a box, or it may be a cubic surface, it may be a spherical surface. So then the flux passing through. The flux means field lines passing through that surface is given by one formula, Gauss's law, Q upon epsilon. The shape and size is not appears in the formula, therefore no length, no radius, even though the cube of sides how much it is, cube of what it is, sides in 9 centimeter mentioned, that 9 centimeter not necessary in the formula. Whatever be the shape and the size of a closed surface, if a charge Q is placed inside it, then the flux is crossing it. Flux means field lines crossing the surface, the field lines cross over there. Then number of field lines is represented by a quantity, that is the flux. Flux is equal to pi is equal to Q upon epsilon naught. Q is 2 into 10 raised to minus 6 coulombs, and epsilon naught value 8 into 854 into 10 raised to 12. Then 2 upon 8.854 is 0.22 phi onwards. Then phi is dropped. Then you have left side is an even integer. Then phi is dropped. Don't increase 1 more. 2 point, suppose it is 215, then if left side integer is odd, then while dropping phi, you have to increase it by 1 more. Therefore, 225 something, phi is dropped, then even 2 is a left side digit is even, therefore you need to increase it by 1. So 0.22 into 10 raised to minus 18, how it is a raised to m upon a raised to n, a raised to m minus 10, minus 6, minus 2, that's equal to minus 18 newtons per coulomb meter square. It is also called Weber. The sign is newtons per coulomb per meter square, because plus phi equals to E into delta S. E is what? Field, newtons per coulomb. And delta S means area, meter square. Okay? Or it is Weber. Another unit for flux is Weber. In electric field, newtons per coulomb per meter square. In current electricity, the flux unit is taken as Weber. Okay? And third problem, a polythene, with the problem on the beginning theory, a polythene piece, a polythene piece is rubbed with wool. So another piece of wool is taken, both is rubbed, is found to have a negative charge. Means polythene piece will have negative charge of 3 into 10 raised to minus 7 coulomb. Estimate the number of electron transferred. Estimate, the first question, the number of electron transferred from which to which. That is the question. So here polythene got negative charge. After rubbing polythene with wool, polythene got negative charge, means so electrons are transferred from wool to polythene. So therefore wool is having some additional, polythene is having some, the electrons is transferred from wool to polythene. Hagagi in the wool polythene, actually additional electrons are there. It is the polythene, it is the wool rubbed. Then electron is transferred from wool to polythene, therefore here additional electrons. Initially number of electrons equals to number of protons in polythene. When it is rubbed, some electrons are transferred from wool to polythene, therefore polythene gets excess electrons. When excess electrons is there, electron is a negatively charged element, therefore here some negative charges are there. So then how many electrons are transferred is the question. By the quantization of charge, Q is equals to n into E. It is the formula for Q. Q is n into E. Okay. So, before that one, here is third problem. Let us for that one later on. A system has two charges. QA is equal to 2.5 to 10 raised to minus 7 coulomb, and QB is equal to minus 2.5 to 10 raised to minus 7 coulomb, two equal and opposite charges, minus 2.5 plus 2.5. Located at the point, 2 points A, 0, 0, it is a coordinate, in the coordinate fashion it is given. I think it is called 0, 0 minus 15 centimeter, 0, 0 plus 15 centimeter. So here it is placed, here it is placed 0, 0 minus 15 and 0, 0 plus 15 centimeter. Okay, 0, 0 means the x coordinate is 0, y coordinate is 0, z coordinate is minus 15. And here 0, 0 means x coordinate is 0, y coordinate is 0, x and y coordinate is 0 means that points comes on the z axis. Okay, and z coordinate is 15 centimeter. I have taken the diagram from it. Look here. So this is the x, y, z coordinate system. X axis, y axis, z axis comes vertical. Okay, the edges of the room represent the x, y, z coordinate system. The edges along the floor is x and y axis. The edges along the wall is what? Z axis. No. So therefore this is the z axis. On z axis at a point B 0, 0, 15 centimeter. Actually the charge QB is placed. This is the origin. Then QA, the charge QA is placed at the point A on the z axis. Why z axis only? X is 0, y is 0. It is the coordinate. 0, 0 is taken 0, 0 minus 15 is taken means it is the x, y, z coordinates. X and y are 0 means it is on z axis. Okay. Therefore the point is on z axis. So on x axis y and z will be 0. On z axis x and y coordinates will be 0. On x axis y and z coordinates will be 0. On y axis x and z coordinates will be 0. 0, 3, 0 is a point on y axis because x and z are 0 means it is a point on y axis. Here the x and y are 0, these are the points on z axis. This is the origin. So minus 15 means y minus is taken, negative side of z axis is minus, positive side of z axis. The points z coordinates are positive. Therefore, what is the total distance between them? AB. AB is equal to OA plus OB. That is AB OA plus OB 15 plus 15. Even though coordinate is minus, the distance is plus. Therefore, OA is 15, OB is also 15, 15 plus 15, 30 centimeter. That's equals to 30 into 10 raised to minus 2. Centimeter is 10 raised to minus 2 meter. SI meter should be taken. Therefore, total now 280. That the separation between the charges is taken as what is 2A in a dipole. The separation between the charges is to be taken as 2A. 2A is equal to 30 centimeters, 30 into 10 raised to minus 2 meters. So, technical point, x, y, z coordinates are given, means you have to identify where the point lies. X is 0, y is 0 means it is on z axis. So, one is left side of the origin, minus means it is below the origin. Another one is point is above the origin because its z coordinate is positive. Positive means it is above the origin. Z is negative means it is below the origin. But distance is positive. 15 plus 15, 30. Okay. The separation between the charges plus q and minus q itself is the 2A in a dipole. So here is a dipole with plus q charge and minus q charge. And the separation is taken as 2A. No? Therefore 2A is that much. What is the electric total charge? First question, what is the total charge? What is the total charge and what is the electric dipole moment of the system? Total charge is QA plus QB. QA is 2.5 10 raised to minus 7. QB is minus 2.5 10 raised to minus 7 is equal to 0. Always the total charge is 0 in a dipole. Total charge QA and minus QA plus Q and minus Q will be there. Total charges are equal and opposite in polarity. Therefore, total charge will be 0. But electric dipole moment P bar is equal to 2A equal to P. P cap. 2A is what? 13 to 10 raised to minus 2 2A. And Q is 2.5 to 10 raised to minus 7. So, any one of the charges should be taken with positive sign. Okay, here for this Q. Go take both the charges, take any one of the charges with positive sign. Okay, then 13 to 2.5, 75 10 raised to minus 7 P cap, coulombs per meter. To the sign, 2A is the distance, meter, Q is the charge, coulombs, therefore meter coulomb or coulombs meter. But 75. So it should be 7.5 10 raised to point is to one place left minus 6 P cap coulombs per meter. So dipole moment means it is a vector quantity or given the direction. Direction is given by the unit vector P cap. P cap is directed from minus Q to plus Q. What is the P cap? P cap is directed from negative charge to positive charge. Here it is QA is positive, QB is negative. Therefore this is P cap. P cap is the unit vector directed from minus Q to plus Q. 7.5 10 raised to minus 6 P cap coulombs meter. Okay. So, but minus 6 is what? Micro. Therefore 7.5 10 raised to point is shifted 1 per left. Then you have plus 1 is to be taken. Point is shifted left. 75 is 75. Point is shifted. Point is shifted 1 place left. Means it is 7.4 into 10 raised to minus 7 plus 1. Point is shifted left means here plus 1 should be taken. Minus 7 plus 1, that's minus 6. Okay. point is shifted left, you are getting plus 1 is to be taken in the power of 10. If point is shifted right, then minus is to be taken in the power of 10. Okay. Therefore, 10 raised to minus 10 raised to minus. Why I am shifting the point? Because in the expression of 10 to the power of a into 10 to the power of b scientific method, a should be a number between 0 to 10. 75 is more than 10, therefore 7.5 is made by shifting 75 from 0 to inside left, then this plus is to be taken plus 1 minus 6. Minus 6 means what? Microcoulomb. Therefore, micro. It is here it is p cap microcoulomb. Okay, microcoulomb meter. 10 raised to minus 6 is taken as micro. That micro is to be included to unit. Okay, p cap microcoulomb meter. This is the electric field dipole moment. Dipole moment of that dipole. Dipole is one. It is a system of two equal charges but opposite in polarity. One is plus, one is minus, separated by a distance 2a. Then it has a physical quantity dipole moment. Dipole moment is 2a into p cap, p bar. Electric dipole moment p bar is 2a into p cap. That's all. So polythene, I have explained already. Polythene problem. If polythene is rubbed with wool, polythene is rubbed with wool. Now actually polythene gains the electron and wool loses the electron. Therefore polythene will become negatively charged. Polythene is rubbed with wool. The wool loses the electron and polythene gains the electron. Which gains the electron, it will become negatively charged because here will be excess electron. Electrons are negatively charged. Therefore wool gains the electron means during the process of rubbing the wool will become negatively charged and polythene here polythene is rubbed with wool. Here polythene gets negative charge means polythene got excess electron. Electrons are negatively charged. Inbuilt polythene sheet is having number of electrons is equal to number of protons. Proton is positively charged and electron is negatively charged with the same magnitude of charge. It is 1.602 into 10 to the power of minus 19 coulombs. That's why inbuilt it is electrically neutral. Number of protons and number of electrons are the same. The proton and electrons are having the same charges but opposite in polarity. Therefore, total charge is 0. Proton charge is 1.602 into 10 raised to minus 19. Electron charge is minus 6.02 into 10 raised to plus 19. Both cancels each other, plus and minus, therefore total charge is 0. But when it is rubbed, some electron, loosely bounded electron from wool is transferred to polythene. Therefore, there is an excess electron in the polythene. Therefore, it will become a negatively charged body. And wool loses the electron, means there will be excess proton. Number of electrons is equal to number of protons inbuilt. But if some electrons are lost, then proton is over what it is. Protons will be exceeding electrons. Number of protons will be more than number of electrons. Then proton is positively charged, which loses the electron, will become positively charged, which gains the electron, will be negatively charged. A negative charge of 3 into 10 raised to minus 7 coulombs is there. Then how many electrons are transferred from the wool to polythene in the question. Okay. So there is a quantization of charge. Number of charge on a body Q is equal to N into E, where E is the charge of an electron. So then you can work out N. N is the number of electrons transferred. Okay. Q is equal to fourth one. This is the end of what it is, electric field. Almost. Here I have taken 13 hours, 13-14 hours, and there in the classroom initially I have taken near about 10 hours, near about 25-30 hours I have taken on this particular what? Electric field. A 9 hours period, 9 hours topic. So here it is, fourth one, A. Q is equal to 3 into 10 raised to minus 7 coulombs. Q is equal to Ne. Therefore, N is equal to Q by E. Q is how much? 3 into 10 raised to minus 7 coulombs. Upon E is 1.602 into 10 to the power minus 19. Wait, so 1.602 into 10 raised to minus 19. Right or wrong, let's see. It is correct, but let's conclude. Calculation ತಪ್ಪು. We had a 1.60 to 1.6 is enough. Okay, in the calculation 60 is not necessary. Now it is 3 upon 1.6. 3 upon 1.6 is 30 upon 1.6. Almost it is 30 upon 1.6. It is 1.31. 16 ones are 16. Then 14 left. 16 9s are 144. Okay, almost nearly equal to 1. Do it in calculator. Then it is into 10 raised to minus 7 upon 10 raised to minus 9. 10 raised to minus 7 minus minus 9. It is not a raised to m upon a raised to n is e raised to m 3 upon 1.6. I had to take it as 30 upon 16. Therefore, 16 ones are 16, 14 left. Then 140 I have taken 5. 16 8s are 128. 1.18 means 80 dropped, then 1.2. 1.8 it is actually 1.8. 128. Then 12 left. 120 means 16 7. Is it not? 16 7s are 112. Then okay, 112. 7 is dropped, therefore 8 will become 9. 1.9 into 10 raised to 1.9 into 10 raised to minus 7 minus of minus plus 90 is equal to 12. That which n is the number of electrons. Therefore, number of electrons, polythene is negatively charged. Polythene is negatively charged means the electron is transferred from where it is wool to polythene. Again, polythene is negatively charged means there are excess electrons in it. Therefore, from where it got the electron? From wool. So, polythene has an excess. Polythene has an excess, or like this. Wool electron is transferred. How many electrons? 1.9 into 10 raised to 12 electrons are transferred. Electrons are transferred from wool to polythene, because which will be negatively charged, it gains the electron. Polythene is negatively charged mentioned in the problem. Therefore, it gains the electron. From where? From wool. Okay. Second question is there any transfer of masses? Even though electron mass is negligible, it is not a massless quantity. Its mass is 10 raised to minus 30 of the order of 10 raised to minus 30 kg. Therefore, some mass is transferred. Okay. Though electron's mass is negligible as compared to proton and neutrons, but it is not a massless quantity. None of the quantities, bodies, materials in the world is massless. Okay. So yes, some mass is transferred. Some mass is transferred from some mass, because the electrons are transferred from wool to polythene means that electrons are having the mass. So that much of mass is transferred from wool to polythene. Some mass has transferred from wool to polythene. Mass is not asked in the question, but for academic interest, I will calculate the mass transfer is equals to mass transfer is equals to n. How much is the electrons? Electron of a mass is E. N into mass of an electron. N is the number of electrons transferred. Mass of an electron is m. How is the mass of an electron? Actually, it is of the order of 10 raised to minus 30 for accuracy. So, its mass of an electron is, mass of an electron, it is 10 raised to minus 30 kg, but mass of an electron is mass of proton. Mass of an electron is 9.11 into 10 raised to minus 31. 9.11. N is, how much it is? 1.9 into 10 raised to 12. And the mass of an electron is 9.11 into 10 raised to minus 31. 31. 1.9 into, it is 9.11. Multiply 1.9 into 9.11. 1.9. 1.9 into 9.19 nines are almost 171. Okay, it is 117.19 ones are 19. 19 ones are 19 plus 120. 19 nines are 171 plus 173. Therefore, it is 1.7309 into 10 to 12 minus 31. That is 10 to the power of 12 minus 31 minus, it is 19, that much of kg. Okay, that's equals to 1 point. I will shift the point 1 place left because your base number should be within 0 to 10. 1.73 into 10 to the power of 731. 731.7309 into 10 to the power of minus 19 kg. Point is shifted 1 place left. Therefore, 19 plus 1, 19 plus 1 is 80. Okay. 1 point left, it is shifted. Minus 90 plus 1. That's equals to minus 18. 1 point is shifted left. Plus 1 should be taken. Minus 19 plus 1 is minus 18. That's equals to 1.7. 3 is dropped. Since it is less than 1, more 5, 1 into is by 1. Into 10 raised to minus 18 kg. That is problem. Mass is transfer. Actually, problem is not asked. This calculation is not asked. Is there any transfer of mass in the question? Is there any transfer of mass? Yes, there is a transfer of mass. Okay, the answer is yes. So mass has transferred from wool to polythene. Okay, this is all about electric field, and in this one derivation and one problem is sure. As far as derivation is concerned, electric field on the axial line of a dipole, electric field on the equatorial plane. Those two are important, and these two more derivations on Gauss's theorem. So electric field due to infinitely long uniformly charged line conductor wire, or electric field due to infinitely long uniformly charged electric plate. The field E bar is equals to epsilon naught, sigma upon 2 epsilon naught into n cap. For a wire conductor, field E bar is equals to epsilon naught upon 2 pi, lambda upon 2 pi epsilon naught into, the problem is taken. So yesterday, today, that problems were discussed. Electric field due to a uniformly charged infinitely long wire, that derivation, plate or wire derivation. Okay, those two are important by using the Gauss theorem. 4 derivations are important. Electric field on axial line of a dipole, electric field on the equatorial plane. Third one is electric field due to infinitely uniformly charged infinitely long wire conductor. E bar is equals to, but it is lambda upon 2 pi epsilon naught in r into n cap. And the fourth one is electric field due to uniformly charged infinitely long plate. E bar is equals to, it is sigma upon 2 epsilon naught into n cap. That derivation. Among the 4 derivation, so one derivation is sure and one problem is also sure. So too many problems are solved, and from the examination point of view, problems are taken. Okay.